All right, good morning, students. Today we are discussing physics chapter 6 sound, and we are discussing part 2. Today we will discuss the characteristics of sound waves, good and bad reflectors of sound, and echo. So first let's get into the characteristics of sound waves. So there are about 4 characteristics of sound that we will be discussing, and the first one we will be discussing is the frequency of sound. Now, frequency is defined as the number of vibrations or cycles in 1 second. As a simple example, I can take a pendulum. A pendulum is basically a metal bob which is suspended by a string in a fixed support, and this pendulum I can move it and cause it to oscillate. So the number of cycles would mean, like, if I take this pendulum and move it to one extreme side and let it go, the pendulum will keep oscillating from one extreme position to the next extreme position, and the number of such vibrations in 1 second is called the frequency. For example, if this pendulum in 1 second of time, if it makes 4 oscillations, this is 1, this is 2, and this is 3, and let's say 4 times, it makes 4 oscillations in 1 second, then it means that the frequency of this pendulum is 4 hertz. Now, frequency is denoted by the letter small f, and the units of frequency is hertz, H-E-R-T-Z, and it is written in short form as capital H and small z. So once again, frequency is one of the characteristics of sound waves, and it is defined as the number of vibrations or cycles in 1 second. It is denoted by the letter small f. The unit of frequency is hertz and denoted as capital S small z in short form. And I have given this as an example. If you have a pendulum which oscillates 4 times in 1 second, the frequency of that particular pendulum is 4 hertz. Next, let's move on to the time period, which is the next characteristics of sound wave. Now, time period, it is defined as the time taken to complete one oscillation. Time taken to complete one oscillation. It is denoted by the letter capital T, and the unit of time period is second, which is denoted by small s. And as an example, if the time taken to complete 10 vibrations is 1 second. The time period is 1 by 10, which is equal to 0.1 second. So once again, time period is the time taken to complete one oscillation. That means, supposing if I bring the pendulum to the one extreme position and start from here, so for this pendulum to travel to other extreme position and come back, the time taken for this pendulum to go to one extreme and come back to the same position, that is called one oscillation. That means starting from here going to the next extreme and coming back, the time taken to complete one oscillation is called the time period. It is denoted by the letter capital T. Unit is in seconds, and as an example, if it completes 10 vibrations in 1 second, so we can find the time period as 1 by 10, which is equal to 0.1 second. So this is the time period. Next characteristic of sound, we will be discussing about amplitude. Amplitude is defined as the maximum displacement of wave on either side of its mean position, and the unit is meter, denoted as small m, and amplitude is basically a measure of energy. Now, for example, this pendulum, I can just slightly move it to the left and it will oscillate continuously, and obviously over a period of time it will slow down, but even then, at least for the duration in which it is oscillating, it will be oscillating with a certain amplitude. That means the distance between this mean position, which is in resting position, to the next extreme position, let's say from here, this distance is called the amplitude. So the amplitude from the mean position, which is here in the central, this is the mean position, let's say I call it MP, and this is one extreme position, let's say I call it EP, let's say 1, and there's another extreme position on the other side, let's say EP2. The distance between the mean position and the extreme position 1 is called the amplitude, and it's obviously the same on the other side as well. Now the frequency of the pendulum depends on the length of the pendulum. So the frequency, let's say, is of a value, let's say for example 2 Hertz. So let's say I oscillate this pendulum with amplitude of let's say 1 centimeter. It will oscillate with the frequency of 2 Hertz, but with the amplitude of 1 centimeter. Now I can easily give it more energy. Okay, that means I can take the pendulum all the way up to here and I can leave it. Now let's say I give it an amplitude of let's say 3 centimeter. Now what will happen is that once I release this pendulum from one extreme position 1, for example, and it swings to the other side, it will swing also a distance of the same length, that is 3 centimeter. So this pendulum, if I bring it all the way up to here, it will swing all the way to the other end, keeping the same distance that I had pulled it away from the mean position, but the point is that frequency will remain the same. So frequency, as you know, depends on the length of the pendulum, and it does not depend on the amplitude. So I can oscillate this pendulum with a small amplitude or with a larger amplitude, and it will vibrate with the same frequency. So once again, maximum displacement of the wave from either side of its mean position, this is called the amplitude. The unit is in meters, and the measure and amplitude is basically a measure of the energy of the pendulum or the energy of the wave. Now moving on to the next characteristics of sound waves. That is loudness and intensity. By definition, loudness is the characteristic of sound which distinguishes a feeble sound from a loud one of the same frequency. It is also defined as the sound energy received per unit area. Now, loudness depends on the following factors. It depends on the surface area, that produces a sound. It depends on the distance, between source of sound and listener, and there are other factors also which I'll write after this. So let me explain. So what is loudness? Loudness is the characteristic of sound which distinguishes it from a feeble sound. Feeble means a soft sound from a loud one. Obviously you know what loud means. Its intensity is much more, little more louder, of the same frequency. The frequency can be the same if you have let's say for example a musical instrument, let's say for example a flute. You know that like if you blow the flute lightly, you will get a soft sound, whereas if you blow the flute really hard, you will get a loud sound. But essentially, if you cover the holes and you keep the holes fixed, the number of holes that are covering fixed, and you blow, you will find that if you blow softly, you will hear sound of that particular frequency, but it will be softer. But if you blow louder, you will hear the sound of the same frequency, but it will be louder. So you can the softness and loudness of sound is basically is the loudness or intensity of sound of the same frequency. Now, sound energy can also be defined as the sound energy received per unit area. That means, let's say you have a surface, and this surface, on the surface you are throwing sound energy at it. So per unit area means, let's say 1 unit by 1 unit, and you have a surface area and you are exposing it to sound energy. So the sound energy basically loudness of sound basically is the sound energy received per unit area, and loudness depends on the following factors. It depends on the surface area. Now, for example, if you have a small drum which has got a small surface area and you beat this with a stick, you will find that it produces a sound. Whereas if you take a large drum and you beat that with a stick as well, you will find that for the same pressure that you apply on the drum, it will produce a louder sound. The reason why this larger drum produces a larger sound, because as you can see, the surface area of the drum is larger, so it produces a louder sound, and the surface area of the smaller drum is small, so it produces a softer sound. Next is the distance between the source of sound and the listener. Let's say you have a drum which somebody is playing, and you are, let's say, standing 1 meter away from it. Let's say a distance of 1 meter. Now you will hear this sound to be of a particular loudness, but let's say if you walk away from the drum and you are, let's say, at a distance of, let's say, 3 meters away from the drum, you will find that although the drum is being played at the same intensity, okay, or with the same amount of pressure or force, you will find that the sound has become softer, and as you go further and further away, you will find that sound has become softer and softer and softer. So the loudness of sound depends on the distance between the source of sound and the listener. So the closer you are to the source of sound, it will appear louder. The further away you are from the source of sound, it will appear softer. Now the other few characteristics on which the loudness of sound depends are for the following. It depends on the atmospheric temperature, that is temperature, it depends on the pressure, it depends on the velocity of wind, it depends on the moisture, it depends on the moisture present in the atmosphere. So the remaining characteristics the remaining conditions on which the loudness of sound depends, besides the two other that I discussed before, that was one was the surface area of the sound, the surface area of the surface that is producing the sound, and the second one was the distance between the source of sound and the listener. The other four factors are the temperature, pressure, velocity of wind, and moisture. Now let us talk about the next topic, reflection. Reflection of sound. Now you can conduct a simple experiment in which, like, you can take two cardboard tubes and place it on a table, and at an angle which is equal from the mean position, let's say angle x, this also is angle x, for example, and you place it on a table surface, and at the end of the tube you place let's say a piece of plywood or a hardwood, and at one end of this you put a ticking watch which can produce a ticking sound, and on the other ear you place your ear and listen to it very carefully. You will find that oh yes, one more thing, you need to create a barrier between these two tubes. Let's say you have a piece of plywood which is creating a barrier so that you can't hear the sound directly from the watch directly to your ear. So, but you'll still hear the sound, because what happens here is that the sound of the ticking watch basically travels through the tube and gets reflected by this hard surface and travels down the other tube into your ear. So this experiment basically proves to you that sound can get reflected. Now we different materials that is available with us are able to reflect the sound differently. Some of them are able to absorb the sound. So we have two types of materials in terms of sound reflection. There is good reflectors of sound, and examples of good reflectors of sound are hard materials, and smooth surfaces, an example of hard materials and smooth surfaces are, for example, metal sheets, and they are concrete walls. These are some of the examples that are good reflectors of sound. So they need to be hard and they need to be smooth surfaces, and examples are metal sheets or concrete walls. They are able to reflect the sound more easily. On the other hand, we have bad reflectors of sound. and they could also be good absorbers of sound. Now these bad reflectors and good absorb sound needs to be soft, and they need to be porous for them to be able to become bad reflectors or good absorbers. And examples are let's say clothes, which is soft, carpet, which is soft, and paper and thermocol. So these are some of the substance surfaces which basically are either bad reflectors or they are good absorbers. So for them, for materials to be bad reflectors and good absorbers, they need to be soft and they need to be porous. Examples are clothes, carpets, paper, thermocol are some of the materials. Now let us discuss the next topic, that is echo. Alright, this is all for today. So we'll continue in the next class. Right, sir.